Thanks for joining us this afternoon. My name is Rick, and I work with Janney Elstner here in Dallas.
My name is David Freisner, and I work with Hines Real Estate Development here in DFW.
And I'm Joe Madrid, and I also work with Janney Elstner.
So Joe and I focus on enclosure performance, and that could be through consulting or commissioning. And as David mentioned, he's on the owner's side. And so we were all talking one day about projects and buildings, and because that's what we do for fun. And we were just kind of talking about what works and what doesn't, right? And so we kind of talked through kind of what is value for an owner, right? What does an owner actually care about? What do they want? And I think there are kind of a couple different layers to that, but two of the things that we were kind of talking about is, one, how can we establish a process that kind of arranges and orders the design and construction process to kind of set this up to get the value that the owner wants? And then two, how can we best technically design and install the building enclosure systems on a building to get what the owner wants, right? And so there's kind of this process side to it and this technical side. And we think that by combining those two things and kind of looking at those two things, we have an opportunity to really understand what owners want on buildings and kind of arrange our scope and our process so that we can help them get there.
So fundamentally, we've got a couple of photos here on the screen just to highlight the fact that the system is a bit broken. These are some prime examples of some issues that we've had, and typically, a building, and when it comes to the commissioning side of it, you're going to have a problem in the design, you're going to have a problem in the execution and the construction, or you're going to have a problem in the maintenance side of the world. But fundamentally, as we talked, a lot of that's because we were just far too reactive through the process, and we're not thinking early enough about how we were going to commission and how we were going to plan these buildings. And so we wanted to be more proactive, and that sort of kicked off the overall start to this presentation and also the way that we together are executing projects moving forward. And so what we are going to talk about today is we're going to talk about the OPR, or the owner's project requirements. This is really where we're going to spend the bulk of our time. This is the roadmap of how the project should go, what is valuable to an owner, what's valuable specific to a deal, because that changes on a deal-by-deal basis, what we can do to maximize the value through the assembly design, what we can do through the field verification process, and then just some next steps for everyone. So owner's project requirements, again, this is where we build the roadmap. And depending on the owner, depending on who you're working with, they may be very sophisticated. They may not have any sophistication at all. And so they may have a process like we do, spelling out exactly how we come about these owner project requirements, or you may literally have to draw it out of them piece by piece. But as we thought through this, we thought through some separate categories, and so we've got that illustrated here. Most of the time, and I think most of our effort on projects is spent in the performance and the operational realm. But in reality, at least for us, this starts significantly earlier, right? We've got scheduling concerns that impact the way we design our buildings. We have budgetary concerns clearly, and that's where my focus is really early on, which is why I need partners, why we need you to help advocate for the performance and maybe some of those other requirements earlier in the process. The environmental concerns, we're going to discuss LEED and some of those pieces, and then also just the overall design intent. We can't lose sight of that as we're working through, but we'll touch on each of these topics as we go through. And then just one note, we are going to pause kind of through our phases and give you all some opportunities to ask questions, because we know we're going to talk for a while, and we want to make sure you can ask relevant questions at the moment.
Yeah, and so before we get too detailed in kind of the technical parts of what could be included from the enclosure perspective in the owner's project requirements, we just kind of wanted to highlight the 4 control layers that we as enclosure people often focus on, and it can be more than this, but this really forms the basis of what most owners are really interested in. And so first we have water control layer, right? And so we consider the building enclosure to kind of be this environmental separator, and we need to keep out rainwater. And so creating a water control layer within the building enclosure is really important because most owners don't want their building to leak. And so we also have some other layers that we care about, such as an air barrier, which is now mostly required by most codes and in most climate zones. And so we do have some requirements for air tightness. And overall, it's just a good thing to have on a building. And then the thermal control layer, so we want to condition the space, and so we need to mitigate heat transfer across the enclosure, and so we're adding insulation to different assemblies, and we can kind of think through that in a couple different ways that we'll talk about here in a little bit. And then finally, there may be a vapor control layer, and that's just kind of maybe including a layer that reduces the vapor drive across a wall or roof assembly if needed, based on your enclosure assembly type and your climate, exterior and interior. That may be necessary as part of the assembly to prevent the accumulation of condensation within the wall or roof.
Okay, and well, here we have a couple of examples. For example, the first image is actually a hospital where you can see the ambulance bay area below, and above it we have some metal panels and ribbon windows. So these type of systems are going to have a waterproofing layer behind the metal panels, and it's going to have perimeter ceiling joints around the ribbon windows. But these type of systems are going to have certain maintenance that's important to upkeep throughout the life of the building. And in this case, we were performing maintenance requirements for these systems because water was getting into was actually the patient rooms. So these kinds of systems, you really have to look at the performance that you're going to get at the beginning, but also the maintenance that you have to continue to do throughout the lifespan of the building.
Yeah, and this is something for an owner that we specifically want to focus on. I mean, again, to have a system that you're going to have to repeatedly go out and maintain that's over the top of an emergency room, not an area that we can normally shut down, this is, in my mind, a design flaw, right? We have to look at the systems, we have to look at the way these buildings are going to operate and pick a system that best supports the overall operation of that building. So a lesser maintenance system would have been a better selection here, knowing the criticality of your emergency room.
Yeah, and from a water control perspective, understanding that different types of spaces may have different levels of tolerance to water leakage into that space. And so the photo on the right is a parking garage. And so we need to understand, does the owner care about this space equal to the hospital space or not? Is there some level of water intrusion into that parking garage that may be acceptable? And that's important because, one, we want to make sure that we kind of identify and document what the owner's expectations are, but then two, we can use that information to appropriately design the assembly and select the materials, right? And so maybe we have a little bit of a tolerance for some level of water leakage into a parking garage, and so maybe we don't need to pay for the most expensive waterproofing, and the owner can use that money somewhere else, right? And so kind of understanding what the space is, what the maintenance requirements are, what the tolerance for water leakage is very, very important for designing the enclosure assembly and selecting the materials. Another thing that we need to be thinking about are the kind of enclosure performance goals and requirements as it relates to energy modeling and the mechanical design, right? And so I'm not a mechanical engineer, I'm not an energy modeler, but I do know that there are criteria within the building enclosure that impact how the building performs from an energy usage perspective and also from a cooling and heating of the space, right? So air tightness and thermal performance and solar heat gain and all these things need to be looked at, identified, made clear up front and kind of reconciled between all three of these people. And so sometimes the mechanical engineer might also be doing the energy model, right? So maybe that gets a little bit more simplified. But we have seen a lot of examples where architecturally, the architect is taking the enclosure and the thermal performance a certain direction with some incorrect assumptions that are getting incorporated into the assumptions for the mechanical engineer and the energy model. And so we have here an example. There are a lot of good resources out there on thermal bridging. And a lot of these resources are relatively new, kind of within the last 10 years, but they're really helpful. And so here's an example from the BC Hydro Thermal Bridging Guide that just shows a typical curtain wall spandrel condition. And so curtain wall spandrels, nominally may have, as seen in this example, an R value of 16.8. But that's the nominal value of the insulation when you just look within a point within the middle of the assembly. But when you incorporate the thermal bridging due to the framing at the perimeter of the spandrel, you can see that the effective R value goes down significantly. And so if you are not accounting for thermal bridging, you are probably significantly overestimating what your thermal performance is. And by accounting for thermal bridging and kind of reconciling that performance and realistically modeling that performance and then realistically including those assumptions in the mechanical design, we think that there can be kind of better value for the owner. And I think in some situations, we actually end up putting too much insulation into walls or roofs because we're thinking too prescriptively about what the code requires and not using other methods to kind of demonstrate code compliance like using an energy model. And so there's just lots of different ways and lots of different things to think about in terms of thermal performance, right? And really dialing in what our actual goals are, accounting for thermal bridging, and really creating good and efficient ways of demonstrating code compliance. And so there is another example here where I worked on a project where I asked the energy modeler, what is the assumed U factor for your curtain wall assembly? And they came back and they said, well, our glazing has a U of 0.21. I said, okay. And by this point, the design was finished, mechanical design is complete, energy model submitted, and I said, well, is that just for the glass or is that for the curtain wall assembly? And they said, well, that's just for the glass. And I said, well, we're putting the glass on the building using framing, right? And so that impacts the thermal performance of this system and it makes it worse, right? Because all of that metal framing that we use to hold the glass is creating some conductive material that's allowing some heat transfer, right? And so the effective thermal performance of that assembly was closer to a 0.4, right? And so there's a disconnect there where we need to be kind of paying attention to that and reconciling those goals and performance criteria in design. Here's just another example. Opaque walls are also no different, right? We often significantly overestimate the performance of the opaque walls. And so here's an example where we have the nominal assembly of an R30, but when we add in the shelf angles and the clips and all these other things, we have an effective R10, right? And so that's a big difference. So architecturally, we need to make sure that we're on the same page with how our buildings are performing from a thermal perspective. And then, yeah, again, just making sure that everyone kind of understands what those criteria are. One of the things that we see are energy models used on a lot more projects. One of the problems I have experienced with energy models is that it takes too much time for the energy modeler to go and model a certain scenario. And so here, we can use an energy optimization tool that some people are using to, in real time, determine different design criteria and how it impacts overall building performance.
And well, we have another element to consider that can seem a little bit obvious, right? The climate of where we're going to build, whatever it is that we're going to build, is going to affect the performance of our building, and it's going to affect our OPR as well, right? If you're going to build something, let's say in Seattle or Portland, where it rains consistently, you're going to want to have a type of waterproofing that's very robust, and it's going to not allow water to enter your building. But let's say that you're building something in Arizona where it scarcely rains, then maybe the type of waterproofing that you're using is not as robust as you would in other areas. And there's a lot of different aspects that go into this, right? It's not only like the temperature that you have outside, but it's the environment that you want to create in the interior space that you are designing. Let's say that you're doing something maybe at a beach location. Actually, Rick and I right now have a project in Puerto Vallarta. So, you don't really want to have a completely enclosed space, but you're still going to have a certain level of performance that you're going to need in your walls. So knowing this information, like where it's going to be located, has to be one of the first questions that you go to your owner and ask. Yeah.
Next is the overall design intent. This is where I see most of the friction between my architectural designers and my commissioning agents and everyone else, right? Is they have this beautiful vision of what they want the building to look like. They run way too far down the process of design before we actually start asking questions related to, but how is this going to perform? And so by involving our envelope consultants earlier and starting to think about this process, we've been able to successfully marry the design intent and the vision of the architect of the project with the performance that we need to be successful. But again, this is an area where there can be consternation and conflict, so it's key to have your owner bought into the model of what you're trying to accomplish so that they can help maintain some accountability, maybe when a designer is specifying something that looks exactly like they want but doesn't perform the way that any of us need it to, and finding a meaningful compromise is critical.
And you don't really have to have this, one team versus another team, which I think happens. I think we've been able to successfully have projects where you really feel like you're all in the same team, right? The building enclosure commissioner with the owner, with the architect. And once you establish that the goal is the same, you can have this really good relationship where the architect ends up being very proud of the building they've created, and then the owner is very happy because that performs to what they were expecting in the end.
So another consideration that needs to be thought through during kind of enclosure scope development and development of the OPR are sustainability or LEED goals. And so we need to make sure that our clients, the owners, if they're asking for enclosure commissioning to achieve LEED points, that they understand what they're getting. They understand what the scope is. And so as you can see, LEED provides some guidance for what the enclosure commissioning scope looks like. And there may be some things in here that are helpful, and there may be some things that maybe the owner is expecting that aren't necessarily required by LEED. So for periodic site visits, for example. So we've found it really helpful to talk to the owner up front and kind of say, hey, look, this is what LEED's asking for. This is what you can expect. Is this really what you want? Another thing to consider is that LEED allows pretty much anyone to do the commissioning. And so from our perspective, this may be kind of unexpected for an owner to have the contractor to do the enclosure commissioning, right? Because you're kind of getting away from that third-party verification. So again, maybe useful, maybe helpful on a project, but something that should be kind of considered and thought through and talked through with the owner.
Yeah, and then we're also talking about carbon. I wasn't able to make the session earlier that talked about carbon and whether it was a buzzword or not, so I don't know what their final answer was on that topic, but it's not a buzzword, it's not a fad, it's here to stay is my personal opinion, because the clients are asking for it, the investors are asking for it, the lenders are asking about it, and also residents of buildings are asking questions about these things. And so when all the parties that we have to answer to as an owner are asking us about a topic, we lean in and we focus on it. So Hines specifically has a decarbonization plan in place. A lot of our corporate clients have decarbonization plans. And so fundamentally thinking through the embodied carbon of a system and also the operational carbon of a building actually comes out when a tenant is coming to tour our buildings, right? They want to know how green, how carbon neutral is this facility before we sign our corporate reputation up to the building that you've developed here. And then decarbonization as a service is something that we offer, but I know that we have lots of consultant friends that are in this room that help us with those things. But we've gone into multiple corporate campuses and helped them develop a plan on how they could enforce their decarbonization or their carbon neutral goals, depending on how they've set those. And so anything that you can do to develop or just highlight your capabilities in the decarbonization realm, I think is only going to grow in its desire and need from other owners as well. One of the key points of the OPR is the scheduling piece. We've got a couple images here, of a hand set brick versus brick set in precast, right? These are decisions that are being made really, really early on in a design charrette when we're determining how quickly we need to get our building to the market. But I need to be able to call and ask really quickly in a design meeting, okay, if we make a choice between these two systems, what are the performance differences, right? And if you I guess I know how to ask that question, but if you have an owner who's oscillating between these two systems and doesn't ask you, you've got to get your hand in the air and say, hey, do you understand the performance differences between the two systems that you're describing? Because we don't want to accept a lesser performing system just to get the building open a month and a half early if over the long haul of a building, especially in light of what we just talked about for carbon, we're hurting ourselves for the life of the building for 100 years to try to save a month.
Well, and then I think another thing to take into consideration is how construction is really changing now. Even in DFW, we now have a lot of buildings that are going up that are prefab completely, right? So everything that's really going to happen in the facade is being made at a plant, a factory. What happens on site is just the pouring of the slabs, and then you're literally building the building as if were Legos. So the scheduling for that type of projects is crucial when you're thinking about something like this, and it's going to affect the entire timeline of your building.
Yeah, not only do these decisions affect the performance, they affect the detailing. Unfortunately, I've been involved in some projects where I'm looking at the details with an architect during construction documents, and they mention that it's a prefabricated wall panel. And that changes things, right? And so it's like, oh, well, we need to completely rethink how we're doing some of this detailing. So understanding these things early on is really helpful.
And definitely not least, but the budget, right? When we're looking at these projects, making a deal pencil is getting harder and harder, and the Fed's not helping us with that. So as we continue to work to make a deal actually push through, we're going to be making selective decisions on which facades need to be, fully thermally broken and designed to a level 10, and which ones we're going to have some, adhered stone. And really thinking through and knowing where we can push and pull that budget, and working with our envelope teams to navigate that is crucial on the front end, just so that they can understand our priorities and help guide the rest of the process.
And I feel like another very clear example of where budget really comes to play, at least on the side of the building enclosure people, is realizing, how the building is going to, areas in the different building, because you might have a waterproofing system that maybe is not the best waterproofing system, but that's okay because you don't really have conditioned space below this area. But now I feel 80% of the buildings have these like huge plaza decks that have conditioned space below. So you're gonna know from the beginning that you're gonna need probably a robust and probably more expensive waterproofing system at these plazas.
Yeah, modern wall assemblies and roof assemblies are layered systems. And so just selecting the water-resistant barrier without understanding the type of cladding and the drainage and where the insulation is going to be limiting, right? And so we need to understand, the budget and how the cladding is going to work and how it's going to be attached so that we can help select and guide the team with appropriate water, air, and thermal control layers. And that brings us to kind of the end of our OPR section. I do want to just take a minute before hopping into the next section to see if there are any questions. Yeah.
My question really is directed toward David. Hines, we do a lot of work with you guys. What are your expectations for commissioning of the envelope? Air door tests, blower door tests, water penetration. What are you looking for from that commissioning side? And that's what we need to, this is talking more about architectural stuff, but I want to see what is your perspective from the commissioning side?
Yeah, no, that's perfect. So for one, I know we can issue a 70-page RFP, and if you've ever received the Hines RFP, pretty daunting. It's 70 pages, and it maybe doesn't even answer the question that you just asked. Well, what do you really want, right? And so I've never been offended for someone to get that RFP and give me a call and say, hey, what does this project really need? What are we doing here? Specific to residential units, we're absolutely doing blower door tests on all of those units. We absolutely are doing performance testing on all of our facade elements. We've got, drones going up with thermographic cameras and checking the full facade of the building. We actually have drones that fly, and there's a company that inspects the entirety of the facade just because we know that we can't actually get out on a swing stage and check every piece of it. So I think our focus is only increasing when it comes to our expectations on the commissioning side of the world. But I definitely think if there's ever a true question on, hey, what does this project need? Because it is project specific, it's investor specific. I wish I could say every Hines deal was the exact same every time, but when I have a different entity that's investing and different lead expectations and different requirements, it's not very cookie cutter, which I know can be hard because again, that 60-page RFP was developed based on lessons learned from who knows how many thousands of countless projects, but it is quite close to the deal, to the location. But again, specifically the items that you mentioned, we're doing every last one of those in our commissioning of development of our deals. Okay. Any questions?
This one's for Rick. You mentioned very quickly that so many times the installation is applied strictly in code, but it was often over-applied.
Yeah, so there are a couple different ways to demonstrate code compliance. Just kind of broadly, you can have a very prescriptive path where you put in the level of insulation that the code says that you need to put in. Or you can do an energy model, right? And so that allows you to have trade-offs between systems. And so that, from our perspective, has allowed us to optimize the level of insulation that we need for the actual building. Does that kind of generally help?
I think I was looking for, you mentioned over-insulation, and that could cause some problems. I was curious about how that went.
Right, well, sometimes we found that there's kind of diminishing return on insulation. And so maybe that point is lower than what the code prescriptively requires.
Question? So in the design phase, so do you find it that, say an architectural team is going to design a roof and an exterior envelope, if they don't hire an building envelope consultant, a commissioning consultant such as yourself, then is it typical that the architect will leave out components like the insulation, the waterproofing, or I mean, is there, it seems like the architect is responsible to provide these things anyways, but is there going to be overlap? Are you there during the commissioning, design phase commissioning, to advise the architect, don't forget the waterproofing or don't forget the insulation?
Yeah, I guess from an owner's perspective, I haven't had a job where the architect forgot to put something in that detail, but the reason that we bring these folks on as early as humanly possible is it's rarely the way that it's actually going to get constructed, and then I'm fighting the change orders when the layers aren't in the right order, it's different from the system that we're actually going to go install, and if I bring them on late, then all they can actually do for me is go say, yes, what was shown on the documents is doing what it was supposed to, but fundamentally what it doesn't answer is that what I actually wanted, right? And so a lot of the effort of bringing this team on board is the architect's worried about the pretty picture, they're worried about the FAR calcs and NRA calcs and efficiencies because I'm poking them really hard on making sure that we have an efficient building, and I need somebody else who's focused on specifically saying, are these details buildable, going to meet the performance that I need? And we're going to get into this as we move into some of our value through design of what is this team doing that is belt and suspenders maybe, but also accretive to the process of getting a design that's much closer to what we're going to build even in the earlier phases of design, which helps me build budgets earlier and helps me really know a roadmap to what we're going to go build. But that's a fantastic question. There is some overlap. They just have a different lens, and you guys have a very different lens than most of our design architects do. That's vital because, again, in the story of developing a building, that lead architect has a huge role, but it's for man, a drop in the bucket compared to me operating a building for 60, 70, 100 years. And so that's why we're engaging this team and people like yourselves significantly earlier. Yeah.
Okay, we're going to talk about enclosure assembly design concepts. There are two reasons we want to talk about this topic. One is the design of the assemblies has a significant impact on cost and performance. And then two, we know that when we have good assemblies and well-defined control layers, it helps facilitate good detailing. I know this isn't a perfect slide because does low cost, high performance actually exist? But what we're really trying to say here is, let's try to find that quadrant where we're maximizing value, right? Where we have the right amount of money spent for the right level of performance. Can you talk about this one for a second?
Yeah, I sure can. This is in answer a little bit to your question. So one of the things that this team specifically collaborated on was to clearly define, hey, what are you doing in each phase of the design process, and how does that tie into what the architect is working on, but in some ways, candidly, just provide some accountability. Because of the questions that we're asking and because of what we're requiring our envelope commissioning and consulting team to do, they need inputs from the architect. And so by defining by design phase what the architect has to supply, it helps me hold them accountable to actually be working through the design significantly earlier. And this does overlap with the building envelope commissioning scope, because again, I'm sure everyone in here, if you've ever looked at a series of construction documents, they're maybe SDs at best, because there's no real definition of what's required at each phase unless we as the owner specifically tell them, I will not accept an SD set unless it has these items, which is the input for them to then go work through the rest of the detailing. And so on the top of the screen on this slide, we have design milestones, and on the bottom of the screen, we have our building envelope milestones and kind of how those feather in together. This was critical for us, and moving forward on all projects, we require this because, again, you're assembling a team that's maybe not brand new to their scope, but brand new on every project, maybe collaborating together. And so to just set clear expectations on what we need everybody to do, and to be able to point back to this and say, no, you have to give me this. One, I'm not going to pay for SDs unless these things are done. So that usually helps folks focus on what we need them to.
And then just kind of zooming in on that a little bit, what we do is we work backwards from what we expect in 100% CDs. So we want good assemblies, we want full, complete specifications, we want detailing, we want isometric details for complex building geometries. So we work back from there and kind of say, okay, if we're going to make that happen, what is the minimum level that we need to have in the SDs, right? So we need to see kind of building plans, we need to see kind of layouts and what the different enclosure assemblies are and where they are and what their function is, so that we can develop the layering, and that therefore will translate through the rest of the design phase, hopefully.
Well, and this is actually just an example about what Rick was talking about. It really is going to change. For example, the first image that we have is just, a direct applied system that's not going to have all of these control layers maybe that we were talking about at the beginning, vapor, air, water. But if we end up with a brick veneer system that's going to have insulation, that's going to have an air barrier water, that's going to have sheathing, all of that is going to create complexity to the assembly details. And I don't know about all of you guys, but now I see a lot of buildings that is going to have stucco on one wall and then metal panels on the other, and then it's going to have a curtain wall system. So figuring out that you're going to have different types of assemblies since the beginning of the project can help you create these assembly details and then kind of assist the architect in a way where they're not doing all the bulk of the work at 50% CD or 100% CD, but you're kind of figuring those things out from the get-go.
So here's just an example of a typical floor plan. And what we do is we kind of outline the plane of the building enclosure and identify the exact responsibility for each separation plane, right? And so you may have many different types of separation requirements for various planes on the same plan. So, just for example, we have a foundation wall where maybe all we need to do is control water. But maybe we have interior walls that are creating an environmental separator between conditioned and non-conditioned space. So we need to think about all these differently, right? And appropriately design the control layers for the specific function of each assembly.
Well, and these are just examples of, right, we're not going to develop these 100% details. What we're talking about is kind of something like this, right? It's just kind of like a conceptual sketch of what we're going to use, but it really also helps us to determine, especially now with a lot of proprietary systems, right? You know, if you're going to use an EVE system, they want you to use a specific air barrier, but if you're transitioning to something different, then you have to change, you know, to a different type of air barrier. So figuring out these where you're going to say like, hey, the first layer that you're going to have is this. The second layer that you're going to have is this. So then David can go and figure out, okay, in my budget, I know that I'm going to need to buy this specific type of sheathing, this specific type of air barrier, and we can also have this back and forth where we know that, hey, do we want an air barrier for maybe something that's just like a frame structure, you know, and we're going to use Tyvek. And David can say, yeah, that's more or less the performance that I'm looking at. Or it's like, you know what, I want a high performance fluid applied, so that's more or less what we're going to specify. That's also going to adjust the budget going forward. And we also added, I was about to switch the slide. We can also do something as simple as a roof assembly, right? It's like, what's the performance that you want on your roof? Is it going to be a green roof later, right? Is it okay if we just install like a single ply? Do you want a PVC roof? You know, all of these decisions and creating those very basic sketches of assemblies can really help going forward.
And I know Joe specifically said it, but this has improved our process significantly by even just having this level of detail at an SD set. My budgets get significantly more accurate, and the trades know exactly what I'm expecting, even if it is a cartoon. And one thing that I don't know that is listed here is we do typically have, you know, a basis of design product listed for each of these layers, so that they can at least know where our head's at. And if they have a different system and want to, you know, provide or equal alternates, they can list those out. But it's been incredibly helpful, and candidly, sometimes these are better than the CDs I used to get.
So that kind of closes out the assembly section. Do we have any questions on kind of the why or the technical concepts we talked about within the assemblies? Yeah.
I got a question. You kind of talked about the difference between the rated, you know, R rating V values versus the assembled values. So when you're looking at like a prescriptive versus performance approach, which one do you use for which? Like, do you use the rated for prescriptive and then the applied for the performance? Does that make sense?
You're talking kind of nominal versus effective? Yeah. It kind of depends. So, you know, if you're doing a model, I would always do effective, right? Because we actually want to model what it's going to be. If you're going prescriptive, there's kind of two different ways. There's an R value method and a U factor method. The R value, you use the nominal. The U factor, you can use the effective. So lots of different ways to do it, even within kind of prescriptive, but yeah, both may be applicable.
Gotcha. Okay.
So there's a project going on, it's a modular build. We're trying to get it put together quickly for an office building. The thermal barrier has been exposed to, you know, the environment, snow, rain for months. Will that affect the integrity of that thermal barrier, and when would you decide on if you have to replace that before they put the exterior wall?
Kind of depends on what the insulation is. Some types of insulation withstand moisture and the environment very well, and some don't. So for a roof, for example, polyiso, it's kind of sensitive to moisture. So it's polyiso gets a little bit wet or something like that on a roof, then, or even used in wall applications now, may need to be replaced. Other types like XPS or mineral wool may have a little bit higher tolerance, but if there's some level of deterioration, then that might be, regardless of whether it's actually affected or not, it might be a reasonable idea to replace it.
Right, and this is in New Mexico, it's, it's getting to it also, it's fading the color of it. I was just curious.
Yeah, and sometimes the manufacturers are helpful in providing some input on that too, depending on kind of what their requirements are. But
Did you just say sometimes manufacturers are helpful?
I did. Any other questions?
All right, we'll keep moving. Okay, field verification. One thing I have learned from the ownership side is that which you inspect, not expect, is what happens. Okay, so if we don't put our eyes on it, we cannot trust that it's actually going to happen. Eventually, we are putting the fate of whether this building leaks or performs the way that we want into the hands of craftsmen who have a million other things on their mind, particularly in a day, maybe not exactly what we want, which is effectively taking care of the building and putting it in the way that we want. And to your question, I think that's an area where in a complement to this team, we fly drones, we take pictures of every square inch of our buildings, we document those at least monthly. So we would get, these guys would then go review it to say, hey, by the way, 3/4 of your, vapor barrier or air barrier has been exposed to UV for the last 60 days. Do we need to look that up? Let's go check out and make sure that we're rated for those things. So there's different ways that we can bolster the field verification where inevitably, I know AI is going to push and we're going to get further and further into that, but right now I still want humans looking at all these things that we're generating. But we absolutely want to check every square inch of that work to make sure that it's going to be effective for our use, and we can't do that by having full-time staff just going and monitoring that. We can only be in so many places at once.
So the time to consider the testing is in the design phase. Historically, a lot of testing has been specified within individual sections, which I think is limited because, one, it's not a concise location where all the testing is provided or summarized. But two, it also focuses on the individual systems. And while we care about individual systems, we care also about how they all interact and interface, right? So specifying the performance requirements in the Division 01 section is really helpful. So here we have our chance to, in kind of a spreadsheet, provide all of the performance requirements, all of the tests that are required, roles and responsibilities, everything in one place. And again, it's coordinated, reconciled with what the owner's project requirements are, right? So depending on what their performance goals are and what their budget is and that kind of thing, we need to adjust kind of up or down the level of testing that we're performing.
Well, and then there's also managing the expectations of those tests. I actually spent most of my time in new construction site visits, right? And you're there and water intrusion quality control testing is happening typically in ASTM E1105. And you do the test, you remove the chamber, and there's this like small drop of water at the sill of the window, right at the glazing, and there's 15 people behind you fighting, did it pass, did it fail? Did it pass, did it fail? All of that goes away if we, in the spec, write clearly what is a pass, what is a fail, because some of these standards will have different language, so it can be a back and forth. And another thing that I think is really important when we're talking about managing expectations is that we want to, as commissioners, not only observe the testing that's happening, but make sure that the correct people are observing these tests, right? Usually, we're going to be testing a window, let's say a punched opening, but that is going to be interacting, like Rick was saying, with the cladding system, let's say stucco, right? And you're going to have a perimeter sealing joint around that. And the chamber, in a way, is going to be putting water on the stucco, the perimeter sealant joint, and the window. So if you have a failure, it's great to not only have the subcontractor for the window, but also to have the sub for the waterproofing and have the sub for the stucco. So in case something fails, you can all like come together and figure out what needs to happen in order to fix that issue. And I think that coordination sometimes doesn't happen, and it is something that can be specified since the beginning. Hey, we're gonna need one of your folks here just taking a look at this test while it's occurring. So I really encourage that these type of coordination really occur while we're doing this testing. And then just talking a little bit more about testing in general, we have like different types of mock-ups that we've been using a lot that are been very helpful. I think lab mock-ups are great, especially when you are designing maybe like a new curtain wall system specifically for this building, right? Because you can do your typical water test, your typical air test, but you're also going to be able to do a structural test of this new system that has been designed specifically for this building. Another type of test that we have, and that's very commonly used, is like an in situ mock-up, where you're probably using systems that have been tested repetitively for a lot of years. So the only caveat here is that you are really trusting whoever is installing these products to install them correctly, because the first time that you're really going to test this system is in the actual building, right? It might be on the first or second floor where you can still course correct if there's something going terribly wrong, but you know, just kind of, there's some back and forth. And then there's a hybrid, which, I don't know, kind of my personal favorite here, because it kind of helps the architect in regards to, like, they get to see the design of all the different elements that they're gonna have in the building. And usually the architect will be like, well, I just wanna make sure that everything looks the way that I want it to, but here's where you really gotta push and say, like, no, I don't want a design mock-up, I want a performance mock-up, like on site, but not in situ. And another thing that's really cool about this is that you're not gonna only be testing like one specific system. You could probably test also the cladding systems around it. You could probably test it prior to having the brick veneer that's gonna go on your building, and just test it when you have the application of your air-water barrier with the sealant joint and the window. And it can also be adjusted to like the owner's requirements in regards to budget, right? Some tests are just more expensive, and that's just a fact. And there are other tests that might be not as complex and less expensive, but you could also be able to see if there's an issue, and you will figure out the issue before you start putting these systems on the building. So just, it's very important to be aware that there are just different type of mock-ups that you can perform that are really gonna help the building going forward during construction.
Okay, and how disappointing is it when we spend all of this time in design phase, reviewing submittals, pre-construction meetings, and we go out, we test, and it leaks, right? So I've worked on 2 different projects and everything in between where you're constantly troubleshooting leaks, trying to figure out what went wrong. And then we've also had buildings where we've done a lot of testing, and we haven't had a drop of water enter the building. So what's the difference? Well, there are a lot of different things, but ongoing weekly coordination meetings are really helpful during construction. Not only do we get to coordinate and talk and figure out who's doing what, how everything's coming together, but we're also constantly reminded that performance matters, right? That we are going to be testing. There are consequences to testing. It's delayed schedules, there's retesting, there's additional testing. So no one wants that. So by reminding ourselves that, hey, this is important to this project, I found that to be one of the things that is really helpful. Multiple reviews, right? During construction, we like to be out there observing a lot of the actual installation of the different systems. While the curtain wall framing is being put together, while those internal seals are being applied, while the perimeter sealant joints are being installed. So being there with the contractor, trying not to annoy them, but really trying to say, hey, we're here to make sure to help you. We want to help. We want to get through this project successfully together. And then finally, just looking at the test areas before it's tested. So again, really easy to kind of spot discontinuous sealant joints, holes in air barriers. Doing a final check before the testing is performed, again, just really helpful. I found when those three things are done during construction, in addition to all the other things that we've talked about, we've just found that that has been really, really helpful in having a lot of successful tests during construction. I know that that is frustrating for a lot of teams. And so we found that, yeah, really just paying attention, being present can be really helpful. Are there any questions on testing before we move into next steps? Yes.
My specific question is regarding sampling. If first window passes, it doesn't necessarily mean that the second and third window also may pass. The same thing with the mock-up. We have had successful mock-up tests, and then on the building we are seeing like obvious, that leakages or damages that had happened during the occupancy. What is your solution to that?
So I'll start. Inevitably, which is part of the reason that I prefer sometimes the in situ mock-ups, is one, we don't tell them where we're going to test right until they've already put it up. Because if we have an in-place mock-up, but that's not, specifically on the building, I'm going to get the most seasoned professional to go do that one installation. I mean, everybody's giving me the best of the best on the mock-up, and then I'm never seeing that person again on the project, right? So we do have quite a robust requirement for the sampling of the windows, and then obviously the retest sampling significantly increases, right? My boss was an auditor and an accountant, and so, man, you start finding a few things in a 20 or 30% look, you're going to start testing significantly more, right? Until we get to consecutive pass tests that are randomized across the building before we finally back away and say, okay, we think we've now resolved these issues. But that's a fantastic point. No matter where it is, if you indicate too early where your test is going to occur, they're going to go put extra effort right there and nowhere else. So randomized and then increasing the number of tests based on any failures is critical to the overall process. Fantastic question.
I have a follow-up question here.
Sure.
Do you prefer the contractor being in charge of performing tests, hiring a third-party tester, or the commissioning agent being the provider of the test?
That's right. I hire that person and works through and with them. So, yeah, I don't want the fox guarding the hen house. Next question. Okay. Next steps. I definitely think a key next step for most everyone here is to have a dialogue with your owners, with your clients, to try to build some consensus that we have, because inevitably if they don't hire you early enough, they don't bring you into the conversation, you can't really add value. But you establishing and working on your own value proposition to go sell to the client, like, here's why I'm adding value, here's the indicatives of what I can do for you if I'm there early, and really building an element of, the ounce of prevention is worth the pound, of cure, is going to be key. Back to the decarbonization and thinking through operational carbon and embodied carbon, anything that you can do to focus on those items and build that also into your sales position to an owner is going to perk their ears up, and they're probably going to listen a little bit more intently because they're all getting asked how they're going to handle that and what they're going to do differently on the next project than they did on the current one. I think are some key next steps to help building consensus. And then I don't know how many owners actually have a formal OPR process. You may actually have to help do that with them, right? I mean, we have a very large, extensive Excel document that goes through every single system, and it's a terrible day, but man, we feel really good after that day's over because we generally have a roadmap for every piece that's happening. So you may have to take a swing at building a draft of that and then go and sitting down and saying, hey, what else would you add to this? What else is important to you that we should be asking and figuring out in the first place? Any other next steps from you?
I think that was good. So that brings us to the conclusion. So we do have probably about 4 minutes If anyone has any final questions, we'd be happy to take those. Otherwise, yeah.
We need a request for occupancy phase scope in terms of envelope conditioning, performance reviews, or go back on any envelope performance metrics that were defined during construction.
Sorry, I missed the first part of your question. Maybe yeah.
Once the project is complete and envelope conditioning is all done, coming back during the performance phase, what types of scope do you typically see?
Oh, yeah, gotcha. Good question. At a minimum, one kind of 10-month post-occupancy site visit is a good idea. We get an opportunity to interview the building maintenance staff. We can kind of review the systems, make sure there isn't anything crazy going on, and kind of have a look just to make sure everything's kind of tracking, and maybe catch some things before that 1 year kind of workmanship warranty might be up. But we've had owners ask for up to 4 to 8 site visits over the course of 2 years, right? So it's kind of a more enhanced kind of check, right? Where, hey, this is a critical facility. We really want to make sure we kind of catch something before something bad happens, or catch maybe before it leaks, that kind of thing. And so I think really the bulk of that work is kind of just final walkthrough, making sure everything's working properly. Our space is conditioned appropriately, and that kind of thing. Other than that, I just don't see a whole lot of value sometimes in doing much beyond that, right? Testing at that point is just, it's hard to fix anything, and so usually kind of just those walkthroughs.
Yeah, echoing what Rick said, I mean, we're going to have something around that 10-month mark in preparation of a 1-year warranty, and then we're going to focus on something typically in preparation of kind of your statute of limitations regarding your latent defect. So again, we kind of pour over that building again to make sure that we're catching anything that's there. Now, once the building's occupied, you tip to catch those a little quicker, and you don't need a random review to find them. But that is a good question, and we do have people come back and audit our buildings to ensure that they're performing the way that we wanted them to. I think that is our time, but thank y'all so much for your attentiveness and questions.